An equipotential grid is generally not required for a factory-built standalone hot tub that is installed outdoors at a single-family dwelling. This is because a hot tub is considered a self-contained unit that already incorporates safety features to minimize the risk of electric shock. However, it's crucial to understand the relevant sections of the National Electrical Code, specifically Article 680, which covers swimming pools, fountains, and similar installations, including hot tubs and spas. The NEC provides detailed requirements for bonding and grounding to ensure electrical safety in and around these installations. Bonding refers to connecting metallic parts to form an electrically conductive path that ensures electrical continuity and the capacity to safely conduct any fault current likely to be imposed. Grounding, on the other hand, connects the electrical system to the earth, providing a path for fault current to return to the source, tripping the circuit breaker or ground fault circuit interrupter, GFCI. While an equipotential grid may not be required, bonding requirements still apply. All metal parts within 5 feet horizontally from the inside walls of the hot tub and any metal parts that are not separated from the hot tub by a permanent barrier must be bonded together. This includes metal piping, metal conduit, metal fences, and any other metallic objects that could become energized. The bonding conductor must be solid copper, insulated, cover or bare, not smaller than 8 AWG. The purpose of bonding is to create an electrically common area around a hot tub, minimizing voltage differences and reducing the risk of electric shock. Ground fault circuit interrupter, GFCI, protection is also essential for hot tub circuits. All 120 volts and 240 volts receptacles located within 10 feet of the inside walls of the hot tub must have GFCI protection. Additionally, the branch circuit supplying power to the hot tub must also be GFCI protected. A ground fault circuit interrupter, GFCI, is a device that monitors the current flowing in a circuit and quickly interrupts the power if it detects a difference between the outgoing and returning current, indicating a ground fault. This rapid interruption of power can prevent serious electric shock. Proper grounding is another critical aspect of electrical safety for hot tubs. The equipment grounding conductor for the hot tub must be connected to the grounding bus in the panel board supplying power to the hot tub. This ensures that any fault current will have a safe path back to the source, tripping the circuit breaker or GFCI. It's important to note that the specific requirements for bonding and grounding can vary depending on the local electrical codes and regulations. Therefore, it's always advisable to consult with a qualified electrician to ensure that the hot tub installation complies with all applicable codes and standards. The electrician can assess the specific installation conditions and determine the appropriate bonding and grounding methods to use. Moreover, regular inspections and maintenance of the electrical system are essential for maintaining electrical safety. This includes checking the GFCI protection, inspecting the bonding connections, and ensuring that all electrical components are in good condition. If any issues are identified, they should be addressed promptly by a qualified electrician. In summary, while an equipotential grid may not be required for a factory-built standalone hot tub installed outdoors at a single-family dwelling, bonding, GFCI protection, and proper grounding are essential for ensuring electrical safety. Consulting with a qualified electrician and adhering to the National Electrical Code, Article 680, and local electrical codes are crucial steps in ensuring a safe hot tub installation. Remember, electricity can be dangerous, and safety should always be the top priority when installing and maintaining electrical equipment. Therefore, always verify with your local inspector and follow the manufacturer's installation instructions.